first person that laughs goes with it.
What?
4-5 continued. And we will be continuing this section for a little while longer than the textbook really wants to do it, because it's extremely important, and I'd rather nail this down. Once we nail this section down, 4-6 becomes simplistic, 4-7 becomes a little bit easier, and 4-8 is nothing. 4-8 would be the applications of triangles and finding sides, 8 sections. So the test will probably be not next week, probably the week after that. And I might teach a little bit of chapter 5 before the test because I don't want a Monday test. I hate Monday tests.
We'll just do a big review day.
Yeah.
That'd be great.
We'll have a big review day, don't worry about that. So today I want to talk about the entire function that we're possibly going to graph. Now I'm going to write sine in here, but it could also have been cosine. The same process is going to work for sine and cosine. It's just the start points that are a little bit different. So this is what's considered the general sine function. It has all the possible features that a sine function can have. It has a number that can sit in front of the sine. It has this linear operator inside the sine. We're not going to get into like x squared and all that fun stuff. That gets a little tedious. And it has this translation that moves it up and down. So A, by itself, this is called the amplitude.
A for amplitude.
So the amplitude is the midpoint between the highest point and the lowest point. It's that middle line. So we consider that the middle line area. The B is related to the period. And I'll be a little bit more specific about that in a second. And C is related to a left-right translation. For trigonometry, they call it a little bit different. It's called a phase shift. But basically, it's a translation to the left or to the right. There's also something called phase lag, phase shift. They use both of those. And then there's time lag, and we'll talk about that one a little bit later. Okay. So, and of course, the K up here is just going to move it up or it's going to move it down. It's just a vertical translation. And that's probably the easiest one out of all of them besides the amplitude. So I need to show you the hardest part of this.
What's the difference between A and A? Between A and K?
A affects the function directly, and it makes it taller. That's all it does.
So it's kind of like when we did, but it's kind of like it.
Gets it closer to the vertical, but this doesn't work that way. This is just going to make them taller.
So it won't ever wrinkle.
It won't
ever make it like shorter.
Oh, you can make them shorter by making A 1/2, 1/10, 1/5, something small. K takes the entire curve and just moves it up or down. It doesn't change the shape of the curve.
Gotcha.
Okay. So the hardest part up here is the inside, this part here. So when you start doing these things, that is the piece that becomes the hardest for most students. What was that? Got it?
Maybe.
I
Gotta
so.
teach.
So what you do is you take the inside of it, and you're going to say, well, bx plus c has to run from 0, the start of the domain, the normal domain starts at 0, and it ends at 2 pi, the normal period.
Oh, yeah.
So we're going to do two equations. We're going to do bx plus c equals 0, and bx plus c is equal to 2 pi.
Is this the one where you said that
Wait, hold
functions
on,
were
I'm
like
confused.
really
You said
crazy,
BX.
so you should do a chart?
Yeah, that's fine.
You said BX plus C.
I set it equal to the beginning of the period. Remember, the period on these things is 0 to 2 pi.
Yeah.
I'm ignoring that it goes off forever. I'm just concentrating on one period. So I need the domain. Whatever goes inside this parentheses is the domain. I need the domain to start at 0, and I need this inside number to stop at 2 pi. Now that inside number is affected by all of this mess. So it's not just x that's going between 0 and 2 pi, it's bx plus c that's going between 0 and 2 pi.
Gotcha.
Okay.
So when 2 pi, I remember we were talking earlier about how 2 pi, when you equal it to the b and the b,
2 pi over
affects
b.
the 2 pi.
2 pi over b.
It has to affect both 0 and 2 pi.
It does. But watch what happens. So if I solve this one for x, what do I get?
C or
C over B.
Negative c over b. This is the new start. Instead of starting at 0, we're going to start at negative c over b. So that's a shift to the left or a shift to the right, depending on if c and b are positive or negative. But it's a direct shift. So if this is negative 2, this will shift literally 2 to the left, because it's been solved out of the parentheses. See, when you're used to parentheses, you look at it and go, oh, it's going c to the left or c to the right, depending on, in here, opposite sign. But once you solve for it, it goes direct sign. So this is, it's going to the left if it's negative, it's going to the right if it's positive.
So the other one, the one that goes up and down K, it doesn't affect it at all?
It doesn't affect anything at all. It just moves the entire graph up and down. All right, so this just gives us the new start coordinate. It has nothing to do with the period. It has nothing to do with period. So this one must have the period built into it. So if I solve this one for x, we're going to get bx is equal to, and I'm going to write it as negative c plus 2 pi. I like that c first instead of second. Whatever happens, do not combine like terms on this side. You have to have two terms. So if this is like pi and this is 2 pi, don't combine them together to be a single pi. Leave them as separate. They have different behaviors. Divide everything by b and you get negative c over b, which is this over here, the new start coordinate. So it gives it to us again. So technically it's saying we don't need to solve this one. We only need to solve this one. It tells us the translation, because it's right here. Divide this by b, and this tells us our period.
Why don't you solve the one on the left?
Just to show you that this piece is the same as this piece, and they're just saying it's the start. So I don't need to solve both of them. I just need to solve this one, because it tells me both pieces. This is the translation, or phase shift. And this one is the period. So it gives us both pieces of information. So right from the beginning, we know the amplitude of this, the translation of it left and right, and the period. And then we can start graphing it. And the k really doesn't affect it too much. The up and down's the easy part, so we'll worry about that last. All right, so far so good?
Yeah.
Let's make it worse.
Oh wait, question.
Already? I haven't really done anything.
Would you still divide the period by 4 to solve the...
We're getting to that. Right now I'm just talking about amplitude, period, translation, the three main pieces. So let's do an example so we can see where all this goes and how it's all going to come together, and then draw a nice little picture.
Why is that with the 2 green circles?
That was just to make sure it was in the right place. I don't like calibrating this because it gets locked up sometimes.
So you do it by hand?
Well, I try to. So, example. Let's look at, I printed off a couple.
You bring it today?
Yeah, right. That's nice and easy. G of x is equal to 3 cosine of,
You dropped something.
I know, pi over 14x minus 3 pi over 14.
He said it's easy.
It is. It looks horrible, but it actually is easy. All right. So on a test, I would say, find me the amplitude, the period, and the translation, or the phase shift, depending on my language of the day. So the first one you can answer right away. What is the amp of this thing?
3.
3. If it was negative 3, what would be the amp of this thing?
3.
3.
Yeah, it'd be 3.
It's the absolute value, because you could care less if it starts high or starts low. It's that distance that it goes up, how far it goes up.
Yeah.
Now the period and the translation, phase shift, I really should use that language, we have to go searching for. We can't just stare at it and figure it out. Well, it is a translation. It's a translation left or right, but in trigonometry they just call it a phase shift. So take the inside, pi over 14 x minus 3 pi over 14, and set it equal to 2 pi. And you start solving for x. Well, the first thing you do is you move this 3 pi over 14 over, so you get pi over 14x is equal to positive 3 pi over 14 plus 2 pi. Alright. Now, the tricky part. I gotta divide by pi over 14, but it's easier to think of it as multiplying by
14.
14 over pi. So if I multiply everything by 14 over pi,
You get
multiply by
3 plus
14 over pi, you're going to get x is equal to, the 14's cancel, the pi's cancel, and you get 3.
plus 2.
Here the 2's, or I'm sorry, the pi's cancel, and it's 14 times 2.
So plus 28.
Plus 28. Now, this is what?
That's that's the end of your period.
That's your period. So this is the period. And this is
Yeah.
Station.
this is the phase shift or
That's where it
translation.
starts. That's where it starts.
It starts 3 to the right. 3 to the right.
Yeah.
So here's what we're going to do. We still have to take the period, which is 28, and cut it into 4 equal pieces. Notice the number is really nice to cut into 4 equal pieces. I designed it this way. So you take 28, you multiply it by a quarter, and you get
Hold on. You didn't just divide
yeah.
You get
But
7.
the
You
problem
get
with dividing
7.
by 4 is if it's a fraction to begin with, you forget how to. It just gets messy. So
You
if you
get
just do
7.
1/4,
You get 7.
it becomes easier. All right, we're going to set up that same type of table.
So there's 7.
Before you get to
Yes.
Go for it.
No.
I have a question on the little pi. 14 over pi part, yes, that. So is that how you
We're trying to solve for x, so I need to get rid
Is
of
that
that.
how you got the 2 pi? Is that how you got the 2 pi?
No, the 2 pi was right here.
I mean the 28, sorry.
Yeah, that's how I got the 28, because pi's go away. 2 times 14. All right, so this normally starts at 0. We're going to increase it by
3.
sevens. Sevens.
No, you have to do it by, you have to go.
No. Period first, translation section. So by 7, so this is 7,
14, 21,
21, and
28.
28. Now, this 3 is going to take this and move all of it to the right 3 units. So technically all you're doing is,
Adding 3.
so 0 becomes 3,
3,
7 becomes 10.
17, 24, and 31.
Good.
So it takes our
It's
graphic.
mental math.
Moves it.
I'm not saying that you can get it.
Now we can graph it. Oop, I forgot to write it over here. Period is 28, and the translation is plus 3.
Phase shift.
Phase shift. Phase shift. Same thing.
Phase shift.
Phase shift. Time lag, but we'll get to that later.
Time lag.
We'll get to it later.
That sounds fun.
When I talk about my Ferris wheel problem.
I hate Ferris wheels.
Isn't that what Miss McCrae designed? We always had a Ferris wheel problem.
Ferris wheel problem.
She told us that we would definitely have a Ferris wheel problem.
I remember those.
Who did?
Our teacher, our pre-cal teacher, Miss McCrae,
Yeah.
worst teacher in the entire world.
Oh well. I do double Ferris wheels.
You do.
How do you do? Is there such thing?
Yeah.
Where?
So I need an amplitude
Yeah,
of
those are real things. Have you never ridden one? They're fun.
Double Ferris wheel.
and 3 down.
Yeah. There's one like. There's
I'll talk about it.
double Ferris wheels like
They're
this.
cool. They're cool.
And then they go up like that. The thing spins.
So you add 3 to everything.
It's like an air coming out of a tire. Barry, we can explain it to her later.
Hey,
So what?
so you add 3 to everything on the bottom row of the thing.
On the x-axis.
So you don't do it there.
Do it where?
The plus 3, the 2 to 3 to 10.
No. The plus 3 is how you got from 0 to 3, 7 to 10, 14 to 17.
Oh.
So let's say this is 3. Then we need to move 7 away from it, so here's 10. 7 away, here's 17. Here's 24. And finally, 31. Mary. So, it's because of what?
She said the with 3 hands. You want it?
It's invisible.
I'll let it take a picture.
Alright, we're taking a cosine graph here. Where does it start?
3.
Well, it starts at 3 and it goes up.
Amplitude is 3.
Amplitude is 3, so it starts high at 3. So here is where it's starting.
Also, it doesn't start on
Not on the y-axis this
Yeah.
time, because it got shifted to the right 3 units.
That's right. That's right.
So it used to start on the y-axis, but now it's starting 3 to the
You're just
Oh.
Can you set the y-axis equal to 3, so it'll be just like starting at the y-axis?
Okay, now I'm
See
confused.
what I'm saying?
No.
Instead of starting with the y-axis equal to 0, can you set the y-axis equal to 3?
No.
And just start from the y-axis.
No.
You mean do this. A vertical translation of or a horizontal translation of the y-axis.
Yeah.
You could do that and call this y equals 3. And plot it right on that dotted line. Yeah, you go ahead.
Okay.
But I mean, it's easy enough to figure out. If this is your first mark, your first dot goes above it or below it or on it. One of the three. All right, where's the next one go?
10.
Right on 10, x is equal to 0, or I'm sorry, y is equal to 0. Then it goes down to -3 at 17, and then back to
24.
24 right on the axis, and at 31 it's back to
Again.
high again. Remember, this thing is
Yeah.
going in this direction, so I usually started a little bit early and ended a little bit late.
I can't draw that.
You get used
I
to it.
can't.
Okay,
No, I can't draw that.
Your
Like that.
ant is 3. Who goes cosine value?
Genius.
I love when people have half a question. When your amp is 3? And I'm like, yes.
I figured it out.
Okay.
The only thing that confused me was your table, because for some reason I thought that was X and Y.
No. This is my table. The way I set it up is both X's is the original cuts and then the translated cuts. So I just create that so I can add it down. It gets complex. It's not as nice as this all the time. Ready for another one?
Sure.
Let's make it worse. Oh, by the way, these numbers are nice because we can consider this axis time. So like at 3 seconds, this thing is 3 meters higher, whatever. At 10 seconds, it's back to the middle. At 17 seconds, it's 3 low. And you get this idea that the thing is just going up and down, like a block connected to a spring that you kind of pull down and let go, and it just
Is
goes.
how they do.
Don't start with
Is this how they do the heartbeat thingy at the doctor's office?
That's more like physics.
Heartbeat's not a function though, because it has those sharp points. It's not a nice function.
Is it like it?
More like electricity as it flows through a circuit, or sound waves as it comes out of a speaker or a synthesizer or something like
Or is
that.
that one whenever you want?
Okay, same process. Right off the bat, we should be able to say, well, what's the amp?
-2 is negative, or it's 2.
2.
Amp.
It's 2.
Shut up. 2.
Two.
No. The.
Door.
Oh.
Period.
I was just saying 2.
I did.
And the phase.
I'll talk
Got a
to
cake.
you now.
You got a cake.
You
Oh.
want to shift?
Up.
Yeah.
Two. There.
Hey, you
But
got a
wouldn't it be
right.
easier to say that the amp is the absolute value of
I did say that.
Then why don't you put it in there?
Put it up there on your paper.
Fine. It's the absolute value of 2, which is equal to 2. There. Kathy.
Absolute value.
Oh, I'm sorry.
Buddy.
There we go. Either way, it falls out 2.
But you still have to keep the negative there, that's the thing.
Absolute
Huh?
value turns
Use
into
it
positive.
For the graphing purposes.
Yeah, you still have to keep
But the amp itself is
Instead of
just 2.
one first, you go down first, right?
Yeah, that's all it does. So, take the inside.
Set
Say
it
you
to
said
five.
it.
Set equal to 2 pi. So you get 3x minus 9 pi over 4 is equal to 2 pi.
So it would be
Nice on
3x equals 9 pi over 4 plus 2 pi.
Yeah. And definitely do not combine these two. You can, but I don't need you to. You want to keep them separate. One's the
It would be
translation.
17 pi over 4
I
if we did
don't
that.
want to do that. Oy. So, first one will be the translation, second one will be the period. Divide everybody by 3 and you get x is equal to.
Wait, divide everything.
9 pi over 12
No.
plus 2 pi over 3.
All right.
3 pi over 4.
3 pi over 4.
And 6 pi.
What?
No, 2
Two
pi over 3.
thirds.
I'm sorry.
2 pi over 3.
What? Oh, that's the same thing I just said, except I said 9 pi over 12.
Yeah, I know, but reduce it as much as possible.
I know, but everyone said no.
9 pi over 12 is not what God
It's
says.
right, it's right, it's right.
It's
Yeah, it is.
reduced.
Divide
They're
by
all
12.
arguing with each other. Let them argue. So, this piece is
Your face shape.
phase shift, so that's here, 3 pi over 4. It's a big phase shift, right?
Really?
Yeah, I don't like it. Oh well. Period.
Just 2 pi over 3.
2 pi over 3. And what do we do with the 2 pi over 3?
Fourth.
A fourth of it. This is where you really want to use the 1/4. So you go 2 pi over 3.
be
cut
pi
it
over
into 4 equal pieces,
pi over 6.
which would be pi over 6. I really don't like that 3 pi over 4,
What?
but we'll deal with
Why
it.
not?
We'll deal with it.
I'm a
Wait,
genius.
which one's
you know
what's
that?
the phase do then?
Just moves it left and right.
So,
Oh.
So isn't
That's what
the,
I'm saying, it's kind of big.
so isn't the
no, it's a
phase
fraction.
is the phase before the period though?
What do you mean? What, do we do it before the period?
No,
No.
like the phase after the is
We do it
when,
after the
like-
period.
No, you're not listening to me. Pi over 6 is here when it's 3 pi over 4 after.
It'll move it quite far, yes. You'll see. Cool. So we cut it into our pieces. Don't get too far ahead of yourself, because sometimes you'll confuse yourself before you even start.
You started at 3 pi over 4,
Start at
right?
0.
Well, I say I start at 0, then pi over 6, then
Pi over 3.
pi over 3, 1 pi over 6, 2 pi over 6,
Oh, I see
3
what
pi
you're
over
saying.
6,
One half.
which is pi over 2. So 1, 2, 3, 4 pi over 6.
2 pi over 3.
And this last number better be the same as the period itself. Alright, then you're going to take it and add, horribly, 3 pi over 4. There's probably
Why
a
did you make
smaller,
this question then?
randomly generated, I gotta fix it in my computer. So, 3 pi over 4 plus 0 is, well, 3 pi over 4. Pi over 6 plus 3 pi over 4.
So much up to it.
Common denominator of
12.
12. This is 9 pi over 12 plus 2 pi over 12, better known as
11 pi over 12.
11
oh my
pi's
gosh.
over 12.
This is
Jeez.
3 and 4 have a common denominator of 12 also, so this is 9
9,
pi over
4.
12 plus 4 pi over 12 is...
13 pi over 12.
Now, this is your hint. To get to from 11 pi over 12 to 13 pi over 12, how much are you increasing by?
2 pi.
2. So the next one's going to be 15 pi over 12, which is better known as...
Well, then why did it jump from?
This is 9 pi over 12. 9 plus 2 is 11, plus 2 is 13, plus this. So 15 pi over 12? 5 pi over 4? Got it. Pi over 4. And then this one should be 17 pi over 12?
Yeah.
That's the nice thing about having equal intervals. You can just pretty much figure out what the pattern is sometimes. Yeah.
Okay. You start off at 2, 3 pi over 4, right?
You start here.
Okay. So you don't start off with 0, 3 pi over 4.
It got shifted 3 pi over 4 to the right.
Um,
Now to draw this is not going to be very pretty.
if we make it all one denominator, would make that wrong?
Actually, it would make it easier to graph.
Wait, what?
If you kept all the numbers in the bottom 12s, it would makes it a lot easier to graph. Because what I'm going to do is I'm going to cut the x-axis into 12ths.
You're smart.
But it's going to
Oh,
take a little bit.
no, you don't.
I need 17 of these things. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
Why did he say
15, 16, 17.
Do we have to do it that way, or can, no, if we use graph paper, can we just do like this is this, this is this, this is this, this is this?
Eventually, yes. But I want to draw this one decently.
Wait, why do you need?
So you can't just be like.
You can. As long as I know what your intervals are, I'm just trying to draw this a little bit more perfect.
So what do the big one?
I want to see what that 3 pi over 4 does. I think I can take the whole graph and shift it a little bit to the left and have a period before 0, I think. But we'll find out. Okay, so it goes up 2, it goes down 2 because of the amplitude. Oh, I got to shift this up 2.
Yeah, so
Yeah,
it's really
so
gonna be
it's
at
4.
4.
Dang it.
Yeah.
So 3, way up here at the top, 4. Now, since it's shifting, the middle line is going to be where?
2.
At 2. I highly suggest that anytime you do a shift, get a nice little dotted line on your middle line.
So I have a question. When we do this, should we do the amp first or the shift first?
The
Okay,
amp is
then
only
we
for
do-
the y-axis.
Hold on.
Oh.
So should we do?
Amp
So
plus
if-
shift.
So why is it?
It's the amp, which is 2, plus the shift, which is 2.
So you do the amp.
Either or, it doesn't matter. As long as you know how high it's going to go eventually.
It doesn't
The
have that.
amplitude is just how far it goes from the.
So
Middle
if the
line
amp was
up.
3, it would be
Basically,
5.
X-axis.
The x-axis up, yeah. So if you know you have to shift it 2 units up, like I should have, I forgot about the 2. What?
So so it doesn't matter that the first 2 is negative, right?
No, that's just gonna flip it upside
What
down.
happens if it's a fraction?
Then it just shifts it a small portion, above the middle line, below the middle line. The middle line is being determined by this +2 here. Yeah, that's Mary Catherine who's now raising her hand. It doesn't matter to me. Go ahead.
I just
I
want to that way.
So if the amp was 3, it would be 2. It would
I'd run out of
rise.
room.
Yeah, but I'm just asking.
I'd run out of room, it'd go off the...
But it would be 5.
I'd have to start all over again. Yeah, it would be 5. You'd have to
I
go up
wasn't
to...
telling you to do 3.
You'd start at 2 and you'd go up 3 and go to 2 and go down 3.
Okay.
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 Alright.
Find your chart.
Which chart? This one? This is from the fourths. So you just go 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And to each one of those I add 3 pi over 4, which is messy. So I just change everything into pi's over 12. It takes practice. It's good fraction work. What's the math?
Very last question. What do those the big 1, 3, 5?
Oh, these?
Yeah, can you label them because they're
5, 10, 15. 5 pi over 12.
Oh,
But I don't want to label those because they're not the important ones.
Very question.
which one?
Well, no, that's not there. The important ones are 9 pi over 12, 11 pi over 12, 13 pi over 12, and so forth and so on.
So those
I
are
know, I
12,
graph
right?
it, I know what it looks like.
It's amazing. Let me do something and it'll answer half of your questions over there. You don't have any questions? Awesome. First off, we're moving this to 9 pi, so that is here. At 9 pi over 12, we're shifting this all the way over to there. Where does the sine start?
Starts at 3 pi over 4.
Well, it's going to start here at 9 pi over 12, which is 3 pi over 4, but where does it start on my y-axis?
-2 pi.
It's going to usually starts in the middle. It's a sine. Sine starts in the middle. Cosine starts high or low, depending on if it's positive or negative. So the sine's starting here.
Oh.
My question is,
And it's going to go down because it's negative. But we have to be careful. It goes down at 11 pi over 12, which is here. So it's going to, this is 11 pi over 12, and it's going to hit right there.
Let's go back to the middle.
Back to the middle at 13 pi, which is here. This is 13 pi over 12, and I'll make it green. And it hits the middle line, which is this line here.
And it goes to 4 at 5 pi over 4. Which is 15 pi
Here.
over 12. It's
This-
15
well,
pi over 12.
5 pi over 4, right?
Yes.
And it goes
to 4.
up to 4, which is way up here.
And then
Wait.
back to the middle.
And it comes back to the middle at the last mark, which is
12.
17 pi over 12.
I'm very confident.
So the graph is going
I didn't get this
Oh, it's up there.
there.
Could have been
So more than likely, we could take this graph and shift it here, and I bet it would fit in perfectly
It
fine.
looks like it has.
very question.
Go for it.
Alright, on the other one, when we first started doing this, the amplitude was negative on the other ones, and so we went down first.
Uh-huh.
How come we didn't do that for that one?
We did
Have
go down.
-2.
We did go down. Sine normally goes up, but it starts in the
Oh,
middle,
yeah,
and it
okay.
goes up.
Right.
But
But it's
it's negative sign,
negative.
so we went
It is
Down
going down.
first.
Okay.
Yeah.
You
Even
just
though,
don't- you just
because
don't
we
miss it.
shifted it.
Yeah.
Don't worry about the shift.
Okay.
Do we have to put all those little marks in it like you do?
You have to label these at least.
Yeah, that's what I.
That's the important part. Make sure they're just equidistant. So if you have to, kind of shift it over and say what this line is, and then do your equal marks. You don't have to do every 12.
Did you have to show the actual distance, like 9 pi over 12? It couldn't have been like sooner. Like,
Oh,
it couldn't have been farther that way.
if you want to do it that way, what you do is you put a little zigzag here, showing that you kind of cut out part of the graph, and then just start. As long as I see these labels as 9 pi over 12, 11 pi over 12, I'm happy. And the general shape going the right way. is important, and how high and how low, and shift it to the right place. So I'm not going to get really, oh, I want a perfect graph out of this. I understand that there's some fluctuations. Like usually, like if it starts at pi over 3 for me, I'll just put pi over 3 here, and then I'll do 4 equal cuts. And you know, kind of estimate it a little bit. Because all I'm going to give you on the test is a graph that looks like this. And I'll have, you know, 3, 2, 1, the lines going horizontal, but I won't have vertical. You get to make those up.
Be on this side of the graph.
We could, well, that's what I wanted to do. If I wanted to go backwards with this one, where would it go? Well, after 2 hash marks back, it would go up. So it would be here someplace. 2 more hash marks, it would be
Middle.
right here.
What?
2 more hash marks, it would,
Middle.
Middle.
darn it. I'm thinking of the x-axis as middle. Here. 2 more hash marks, and it would be here. 2 more hash marks, and it would be
Middle.
middle. So we could have started this thing at pi over 12 and have just a translation of pi over 12, and it would be the exact same curve, just shifted a little bit more that way.
Wouldn't that be like finding a reference angle?
Reference angle. Similar.
Well, yeah.
Yeah. Once you know the period, you can see if you can shift it, fit it into this portion. So this is probably the same as,
Can we?
God, it would be hard to figure out. We'll do that later, though. I just have the translation too big in this case. There's ways of fixing it.
It's hard to do that. Go backwards.
Well, that's the thing. The graph goes on forever in both directions, so you can go forwards, backwards. You can go backwards even more if you want. And it's real easy. You just do more marks.
What is it,
I actually want to do both of them.
And there are 8 sections, you said?
There's 8 sections in this chapter, I think.
So we're looking at our test again.
Next week.
Next Wednesday?
Next week sometime.
Next Tuesday.
Next Wednesday. Yeah, 8 sections. Make it a little harder as we go. So continue 4, 5. Let's finish up going backwards with these trig functions. If they give you a trig function, you can find the amplitude, the period, the phase shift, and any transformations up and down. So what I want to do is go backwards because sometimes that's more important. For instance, if I tell you that the period is 100, the translation is negative 10, and the amplitude is 5.
What's 2 again?
Translation or phase shift. Phase shift.
Okay.
But think of it this way: it's been translated 10 units to the left.
So T is like C?
T is related to C. It's not exactly equal to C, so you have to be a little cautious with it. So if I say, well, I want to make this a cosine function, the basic setup of a cosine function is this, without the plus k on the end. I'm not moving this thing up and down, I'm keeping it on the x-axis as the center line. So what we want to do is kind of go backwards and take the given information and find A, B, and C. Of course, the easy one is A. A automatically becomes 5. That's just the easiest part of this whole thing. So 5 cosine. Now we have to go and search for B and C. What's that?
I know it's negative 5.
It doesn't say anything about being flipped, so you just assume it's positive. If I'm going to get really specific, I'll say it's going up or going down, or has a maximum in first, you know, something more. But if I don't say anything, just leave it positive. So how do I find B? Well, you do it exactly like you would do a graph. You would set up bx plus c is equal to 2 pi and solve. And the pieces become what you expect them to be. X is going to equal negative c over b plus 2 pi over b. We've seen this before.
What are P, like, are P and T just different variables that we came up with?
I just call that period in this translation.
So it's basically B and C.
No, they're related to.
Okay.
All right, related. Now, what is this part of it?
Phase shift.
That's the phase shift or the translation, right?
I was wondering where you were going with the P.
And this part over here is
The translation. The phase.
the period,
Yeah.
period of the function. So I said up here the period is equal to
100.
100. So 2 pi over b must equal 100. So you go down here and you go 2 pi over b, set it equal to 100. So the only thing that we don't know there is b. So how do you solve for b real quickly?
on multiplication.
You switch the 100 and the b.
Oh, okay.
That's
Do
a quick,
that too.
because it's a proportion. You can set it up as b or 100 over 1.
Do that too.
So you get b is equal to
Pi over
pi over 50. So now we know what b is equal to. We can come over here and say, well, that's pi over 50 times x. Now I don't know if it's plus c or minus c. We'll get to that in a second. Now the translation, it says, is negative 10, right? And negative c over b has to equal that negative 10. Has to be shifted 10 units to the left. Now, I'm looking for c. I already know what b is. B is,
Pi over 50.
but I highly suggest you write this as positive c is equal to negative 10, or I'm sorry, positive 10 times b. Get the b on the other side. Because if you put it in the fraction form, it gets kind of weird looking. It's better to have the b on the other side. So this becomes c equals 10 times, well, what is b?
Pi over 50.
Pi over 50. So c has to equal
Pi over 5.
pi over 5. And it's positive pi over 5. So when we come back over here to the sine function, we just go plus pi over 5. And you're done. This function has an amplitude of 5, has a period of 100, and it has a translation 10 to the left. Decent? Huh? This function, since we designed it, has a period of 100, a translation of 10 to the left, and an amplitude of 5.
Yeah.
So it fits all the given information.
I have a question. Since that has parentheses, it does the opposite of what you expected
The translation, right.
All right, but are we supposed to assume one that without parentheses to do the same, or no?
Well, if it didn't have
Because in
parentheses,
the book, it's like kind of
it gets confusing.
assume that you have parentheses sometimes.
Here? Or
Yeah.
inside of there?
I'm talking about like the book. Sometimes the book gave it, and we put it. I don't know.
Well, if they give it to you, you're trying to graph it, so you're trying to find the period in translation. This one, you're given the period in translation, and you're trying to find the numbers that go on the inside.
Yeah.
It's just backwards thinking. So, one for you. Might as well see if you can do it. Let's let the period equal 3 pi over 4, and let the translation be pi over 6. Positive pi over 6.
What's that?
Amp 3. Let's make this one a sine function. Really doesn't matter.
Then I'll give it that.
Yeah, I'll give you this part. Everything in black I'll give you. Now you got to come up with the rest of it. Find me A, B, and C. Find me A, B, and C.
I'm already.
Trying to speed you up. Accelerate. Alright, shouldn't take you that long. Here's why. Negative 2 pi over b has to equal what? 3 pi over 4. And you have to solve for b. So here you might want to just do the cross multiplication. So if you cross multiply, you get 3 pi b is equal to 8 pi. Right?
Yeah.
Okay. Divide by 3 pi and you get b equals
8 pi over 8. Or 8/3.
8/3. The pi's are going to cancel. So if we know that b is equal to 8/3, we need, this is the translation part. In the translation, we want it to be pi over 6. But like before, I said make sure you move the b to the other side and also the negative. So you get c equals negative pi over 6 times b. But now we know b is 8/3. So c is equal to negative pi over 6 times 8/3, better known as
Negative 4 pi over
negative 4 pi over 9. So when you plug this back into the function thingamajiggy, you get y is equal to the amplitude,
9.
3 sine of 8/3 x minus 4 pi over 9. And this would be a function that has a period of 3 pi over 4 and a translation of pi over 6 to the right. Not that hard, right? And if you forget the formula, you always take this and set it equal to 2 pi and then just solve and see what happens. Okay. So how is this related to a Ferris wheel?
It's not.
It is,
It
but
is.
I don't remember. Our teacher told us that we were going to have a Ferris wheel on the exam last year, and we did.
And you did?
Because of the.
Well, if you have
Told
a
us
Ferris
she
wheel,
made- She had us do like 7 on, not on the exam, but like. we tried on
it's not a very perfect Ferris wheel. So here's the center of the Ferris wheel. The Ferris wheel has a certain radius. And you want your car to get picked up down here.
Car?
The thing you sit in. I think it's called a car. Or a seat, I don't know. Now what's going to happen is this Ferris wheel is going to go around with a constant rate, some angular velocity. Remember angular velocities? So it's going to have a certain angular velocity, and that angular velocity is going to have an effect on the car's linear velocity. We can calculate all that out in a little bit.
Are we going?
My interest is how high off the ground after a certain period of time. So I want to find a function that will give height off ground at t seconds into turning. I don't know if you've ever been on a Ferris wheel, they're kind of boring. They just
No, they're
go
not.
around and around. So our Ferris wheel is going to kind of go backwards. We're going to look at it going this way. Regular old counterclockwise, so our angles are always positive. And we're going to do this with a sine, and the reason we're going to do it with a sine, let me use a different color here, is if our car is here, then the height off the ground that it's going to be is going to be the y coordinate. If you think about this in an xy plane, and throw the the y-axis, make it go right through here. All right, so if this is the height, and we talk about this in trig form, this is usually cosine theta, sine theta.
Yeah.
If we're talking about just an angular velocity of a unit circle. We'll switch it over in a second. Which one of these is going to determine the height of our Ferris wheel?
You said the y, right? So
It has to be the y, so we're going to be working with a sine function. So number one, sine function. We know that. Now, you have to know a little bit about this Ferris wheel to figure out the next couple pieces. The amplitude, where's the amplitude going to come from?
The
R.
The radius. Because it's going to go r high and r low. Even though the Ferris wheel is brought out of the ground, this is going to have a little transformation of plus whatever r is to get it out of the ground, so you're not hitting the ground. So 2, we know the amp is equal to r. Whatever the radius of this Ferris wheel is, that's what our amplitude is going to be. The problem is, my cart is not going to start when the angle is equal to 0, because the angle equal to 0, my cart's up here. And that's not where we want to start. We want to start way down here. So I need to do a translation, a phase shift. Oops, 3. We need a phase to the ground.
Whoa.
And before we can even figure out what the phase to the ground is, we need revolutions per minute. That'll tell us our period, eventually. So, given all this information, you should be able to come up with a sine function that correctly describes how high off the ground you are at any time on this Ferris wheel. All right. So, give me a revolutions per minute that won't kill us. 10 revolutions per minute. Oh my God.
Let's do 1.
Oh, that would even be boring.
10.
Take a whole minute to get around.
about
this
3?
That's how it usually is.
Yeah.
No, not that bad. So,
No,
10
let's do 5.
revolutions per minute. We're going to go kind of fast. We're going to get launched out of this.
Yeah.
So, if we're doing 10 revolutions per minute, do you remember how to transform that into angular velocity?
Hold on, let me go back to my head.
The pi.
Don't you dare. Angular velocity of this thing is going to be
D
2
equals
pi.
RT.
2 pi times
10.
10. And this will be per minute. So the angular velocity of this thing is 20 pi per minute. Okay. Just a little reminder of what's going on. Oh, let's give this thing a radius. Let's not make it too big. 5 meters. So let's say the radius is equal to 5 meters. So this would be given information also. Those are the two main pieces for this whole problem. So I know my angular velocity is 20 pi radians per minute. Is that pretty fast? Yeah.
Did you just make up 5?
Yeah, I just made it up. Just made it up. So here's what we need to do. Number 1, I need to know the period of this graph. So if I start here and I come all the way back around, how long does it take me?
20 minutes.
20 pi.
2 pi.
You gotta be careful here.
Wait,
1
wait.
revolution takes how much time? So it's
20 pi per minute.
time per revolution.
20
10
pi.
minutes.
2 pi per minute.
Okay, hold on.
Can
It's
you get 2 pi?
10 revolutions a minute, right?
Yeah.
I need to get this down to the number of revolutions in 1 minute. No, how do I want to phrase this?
Yeah, it's 10 revolutions.
Switch it.
in 1
How much
minute.
time does it take to go 1 revolution? How much time does it take
It
for
takes
1
6
revolution?
seconds.
1 revolution equals how many seconds?
6.
6. How'd you find that out?
Because you did 60 divided by 10.
60 seconds divided by 10 revolutions per minute. And that'll give you 6 seconds. Every 6 seconds, this thing's going to go around once. And then you do that by 10, that becomes 60 seconds, that becomes a minute.
Jesus.
It's going pretty fast. Now, from that 6 seconds, it takes 6 seconds to go all the way around. I need to shift this thing from the far right on the unit circle, the 1, 0, down here to 0, -1. So how many seconds would that be?
Wait, say what?
How many seconds will it take you to go from this point and drag it back if we do 1 revolution in 6 seconds?
Oh, it would take
3
us
over 2.
6 divided by
4,
4.
which
It's
is
a quarter of a rotation,
3 halves.
which is 3/2 of a second. So 1 revolution is taking 6 seconds. This is
That
our
makes sense.
period. And what was the other one? 1/4, so 3/2 of a second. This is our phase shift. Phase shift.
Can you take that translation off?
All right. With these pieces, well, is it positive or negative? 3/2.
Well, if it's going back, it's going to be
It's
negative.
got to be negative because we're coming back to the ground.
Why are we
backwards.
going back to the ground?
Because our rotation is normally, in our case, clockwise. So we have to come back, so that's going backwards. Because I want to bring my car from standard place, where sign starts usually here.
Oh, okay.
I need the sign to start way down here,
Gotcha.
so I can get on the car and then go around. All right, so using these two pieces of information, and we have 2 pi over, I wrote it backwards. 2 pi over b, what is that going to equal?
2 pi over b
Yeah.
equals negative 3
What is this related to?
Period.
Period,
Which is 6.
which is 6. So this is equal to 6. And the phase, we're going to get negative c over b is equal to
Negative 3 halves.
negative 3/2. All right, let's deal with the period first.
Where'd you get the 3 halves?
The 3/2? If I know my period is 6 seconds, it takes 6 seconds to go from this point all the way around back to this point, right? I need to bring my circle back a quarter of a turn. So how many seconds is a quarter of a turn? Well, 1/4 of 6, which is 6 over 4, 3/2. All right, solve for b, what do you get?
Pi over three.
Pi over 3. Solve for c. Let's see. This becomes c equals 3/2 of b,
Which is, it's pi over 2.
which is pi over 2. This one I expected. Why? Because I rotated pi over 2 degrees over there. 90 degrees rotation. All right, so my function that relates to this Ferris wheel is y equals, what is my radius? 5. This would be sine of
Pi over 3.
pi over 3. I'm going to call it t.
T.
T for time
Plus pi over 2.
plus pi over 2. And this function would describe the motion of that Ferris wheel's height off the ground at any time you want it to be. Just substitute in a t and that'll generate how high off the ground you are. So if you want to know 10 seconds into this trip, where are you?
And
You
it's
can
always
plug
going to be
in 10.
sine. Could we do, it's always going to be sine.
It doesn't have to be sine, it can be cosine. But the physical relationship is sine. But there is a relationship between that function and
What
cosine.
is that beside pi over 3?
I don't want to know that.
T. That's my t.
Question, what if the Ferris goes a certain distance off the ground?
Well, that's the thing. We need to bring this thing a certain distance up. What would be a safe distance?
2 feet.
12.
So it's already got 5 meters of radius. So if you have it at 5 meters, your car is not going to have much room to pass through the floor. So you want to bring it up a little bit higher than 5 meters, say.
10.
Okay, yeah, sure. Let's crawl up to the car. Maybe 6 meters, maybe 5 more 5. So you probably have to add on at least 6 meters. And you can have stairs going up to it or
I was
something.
wondering where you get the -3.5, which is the
This one?
Yeah.
It's a 6-second turn for 1 full rotation. I want to go back a quarter of a rotation.
Oh,
So it's 6 over 4.
And why are you adding 6 to it?
Because otherwise our Ferris wheel goes into the ground.
So are we like, did you just pick 6 or?
Well, it's 5 meter radius, so I at least have to bring it up 5. But then the car might be swinging a little bit low, so I brought it up a little bit higher.